Hello everyone. In the beginning of the class, let us see new announcements. Okay, the first new announcement is June 6th, 2022 class videos uploaded. Hello everyone. I have uploaded the class videos on June 6th. 2022 to YouTube. Their URLs are this, and this. Okay, best regards, Wei Zhen. Okay, and the second new announcement is today is the last day of class. Hello everyone. According to the school calendar, June 10th, 2022 is the last day of classes for this semester. So today, June 8th, 2022 is the last day of this class for this semester. Best regards, Wei Zhen. Okay, the third new announcement is the slides of Chapter 4 have been updated, version 2022-0608. Hello everyone, I have uploaded the latest version of the slides of Chapter 4 to the eCourse2 website. The location and the file name are eCourse2 website, multiple input, multiple output techniques for wireless communications, course content, slides, chapter 4, slides 2022-0608.pptx. Best regards, Wei Zhen. Okay, and the fourth new announcement is the handout of Chapter 4 has been updated, version 2022-0608. Hello everyone, I have uploaded the latest version of the handout of Chapter 4 to the eCourse2 website. The location and the file name are eCourse2 website, multiple input, multiple output techniques for wireless communications, course content, handouts, chapter 4, handout 2022-0608.pdf. Best regards, Wei Zhen. Okay, and the fifth new announcement is the slides of Chapter 5 have been updated, version 2022-0608. Hello everyone, I have uploaded the latest version of the slides of Chapter 5 to the eCourse2 website. The location and the file name are eCourse2 website, multiple input, multiple output techniques for wireless communications, course content, slides, chapter 5, slides 2022-0608.pptx. Best regards, Wei Zhen. Okay, and the sixth a new announcement is the handout of Chapter 5 has been updated, version 2022-0608. Hello everyone, I have uploaded the latest version of the handout of Chapter 5 to the eCourse2 website. The location and the file name are eCourse2 website, multiple input, multiple output techniques for wireless communications, course content, handouts, chapter 5, handout 2022-0608.pdf. Best regards, Wei Zhen. Excuse me. Okay, next let us look at the progress of the last class. In the last class, we have taught to chapter 4, slides, page 212. It follows. Okay, so please open the slides of chapter 4 and turn to page 212. Okay. So since we have argued that the means of x and y are 0, okay, what is x and y? Oh, sorry, what are x and y? Okay, let us review it. Okay, denoting the first bracketed term by x. Okay, so this term is equal to x. And the second by y. Okay, so this term is y. We can write, nothing. Okay, so this is x and this is y. Okay, the means of x and y are 0, okay, which we have proved on the blackboard. It follows that the variance of h of k, which we denote by sigma h squared, can be expressed as, okay, sigma h squared is equal to the expectation of the square of the absolute value of h of k. Okay, why? Okay, let us see the reason. Okay, because on page 200, h of k is equal to x minus jy. Okay. Okay, now because x and y are 0 mean, so h of k is also 0 mean. So the variance of h is equal to the second moment of h of k. Okay, and because h of k is a complex random variable, so we need to add the absolute value. Okay, and because h of k is equal to x minus jy, so the square of the absolute value of h of k is equal to x squared plus y squared. And because the expectation is a linear operator, so we can split them apart. So we can write that as expectation of x squared plus the expectation of y squared. Okay, this equation number is in the wrong place. Let me correct it. Okay. Okay, and we know that the variance of x is equal to, okay, let us see. Okay, x and y are IID 0 mean Gaussian random variables with equal variances sigma square. Okay, so if we can show that, okay, we already show this fact. Okay. Okay, so let us go back to the page 212. So the variance of x is equal to sigma square, and the variance of y is also equal to sigma square. And because the means of x and y are 0, so the variance of x is equal to, so the second moment of x is equal to the variance of x, and the second moment of y is equal to the variance of y, okay, which is equal to sigma square plus sigma square, and is equal to 2 sigma square. Okay, since we are considering flat fading, the non-normalized version of the system's equation is given by equation 4.41. Okay, let us go to equation 4.41. Okay. Okay, we can see that in equation 4.41, oh, the equation number is again in the wrong place. Okay, so let me correct it. Okay. Okay, in equation 4.41, r of k is equal to h of k times s of k plus z of k. Okay, where r of k is defined as r of tk, and r is the low pass equivalent received signal, and h of k, okay, let us see h of k. Okay, h of k is defined as capital C of tk0, where the capital C is the frequency response of the channel. And S of k is defined as U of tk, where U of t is the low pass equivalent transmitted signal. And finally, Z of k is equal to the noise. Okay, let us go back to page 213. Okay, here is the hyperlink. Okay, in the absence of thermal noise, it follows that the square of the absolute value of r of k is equal to the square of the absolute value of h of k times the square of the absolute value of s of k. Okay, we can therefore write the received signal power PR is defined as the expectation of the square of the absolute value of r of k. In terms of the transmit power, PT is defined as the expectation of the square of the absolute value of s of k as follows. Okay, PR is equal to the expectation of the square of the absolute value of h of k times the expectation of the square of the absolute value of s of k. Okay, again, the equation number is in the wrong place. Okay, so let me correct this problem. Okay. Okay, and this is equal to 2 sigma square PT. Okay, because the first term, okay, according to equation 4.59, the first term is equal to 2 sigma square. Okay, and the second term is defined as PT. Okay, where we have used the fact that h of k and s of k are independent of each other in the first line. Okay, this line. Okay, and the relationship given in equation 4.59. Okay, let us see equation 4.59. Okay, we have used this equation, the expectation of the square of the absolute value of h of k is equal to 2 sigma square. Okay. Okay, combining equations 4.60. Okay, let us go to equation 4.60. Okay, we can see that PR is equal to 2 sigma square PT. Okay, and equation 4.58. Okay, let us go to equation 4.58. Okay, this is equation 4.58. Okay, and the equation number is in the wrong place. So let me correct this problem. Okay, so in this equation, probability density function PDF of the absolute value of h of k can be written as this equation because the absolute value of h of k is a Rayleigh random variable. So its PDF is f of the absolute value of h of k of x is equal to x over sigma squared times exponential negative x squared over 2 sigma squared when x is greater than or equal to 0. And f of the absolute value of h of k of x is equal to 0 otherwise. Okay. So let us go back to this slide. So combining equations 4.60 and 4.58 allows us to rewrite the PDF of the absolute value of h of k in the following form. Okay, let us see f of the absolute value of h of k of x is equal to 2x over PR over PT times the exponential negative x squared over PR over PT. Okay, it is, the equation number is in the wrong place. Okay, let me correct the problem. Okay, please wait me a moment. Okay, good. So how do we get this equation? Okay, let us see equation 4.58. Okay, this is equation 4.58. Okay, and let me write this on the blackboard. Okay, of course I do not have a blackboard, so let me use the Microsoft Word instead. Okay, so this is equation 4.58. Okay. And let us see equation 4.60. Okay, this equation. Okay, this is equation 4.60. Okay, good. So how do we get the equation 4.61? Okay, let us see. Okay, so it is, okay, let us see, chapter 4, page 215. Proof equation 4.61. Okay. And the following is the solution. Okay. And problem 1 should be bold. Solution should be bold. Okay. So, from equation 4.58, we know that, this equation, and we renumber this equation as equation 1, and from equation 4.60, we know that, PR, this equation. So we renumber this equation as equation 2. And change this comma to the period. From equation 2, we have. Okay, so okay, let us see. Sigma square is equal to PR over PT. Oh, sorry, PT. Okay, and this is equation 3. Oh, sorry, not PR over PT. It should be, okay, PR over 2PT. Okay. Okay, so substituting equation 3 into, into equation 1, we have, okay, so we have this equation. Okay. Okay, and sigma square is equal to PR over 2PT. Okay, so we can simply replace the sigma square, okay, by this term, okay, like this, and this sigma square, okay, by this term, okay, like this, okay, and we should use a dot here. Okay, good. Okay, and this is equal to, okay, let me delete this period. Okay. Okay, so this is equal to, okay, okay, so we can simplify this equation. Okay, first let us remove the 2, factor 2 to the numerator. Okay, and we have 2x. And let us see equation 4.61. Okay, we can organize the equation into this form. Okay, so in so in the denominator is PR over PT. Okay, so we can rewrite this equation as, okay, a parenthesis and a fraction. Okay, so this is PR. Okay, and this is PT. Oh, sorry, PT. Okay, and for this term, okay, let me delete this first. Okay. Okay, delete the exponent first. And this is equal to a fraction. Okay, and the numerator is x squared. And the denominator is a parenthesis. And in the parenthesis, there is a fraction. Okay, and it is PR over PT. Okay. Good. So let us call this equation, okay, equation 4. Okay, and align at the equality sign. Oh, I can't align at the equality sign. Okay. However, it is the problem of the Microsoft Word. Okay, so I insert some spaces, okay, to make them align. Okay, so finally we have proved equation 4.61. Okay, just as this equation shows. Okay, and let us define. Okay, G is defined as PR over PT. Then here, PR over PT can be replaced by G. And here is the PR over PT replaced by G. Okay, so where G is defined as PR over PT, okay, it is 25 minutes. let us take a break.